Welcome to today's class, and this is basic science class. Very quickly before we dive into a topic, I have a question here, which is, how is ceramic molded? How is ceramic molded? Most times we have this ceramic products at home. We have it in our plates, cups, and other utensils. But have we ever stopped to think that how do we mold this ceramic? How are they gotten? So that leads us to our topic today, which is non-living resources. Do not forget that in our previous class we looked at the living resources, that is materials derived from living resources, and now we are looking at non-living resources. At the end of today's class, you should be able to identify resources that are derived from non-living things. You should be able to classify them, state their properties, and also their uses. So non-living resources are materials or substances that are not derived from living organisms, but also they are essential for human survival. They are not derived from living organisms, but they are essential for human survival, and they play a crucial role in various aspects of human life and development. They play a crucial role in various aspects of human life and environment. Very quickly, we're going to look at some of these examples. We have our wood, we have the tree, you can see on the slide the wood, we have water, we have air, we have metals, and we have fossil fuel. We also have the glass, mineral resources, and ceramics. So we're going to take them one after the other. We're going to look at their production and how it is useful to man. So classification of resources from non-living things. Number one is glass, and we're going to look at glass production, the processes that takes place before we have our glass. So glass is a versatile and widely used material that is derived from non-living resources. So it is derived from the primary resource from where you get your glass is silica, and you get your silica from sand, along with other additives. So when you add your soda ash and limestone, and you have your glass. So we're going to look at the step-by-step production of glass. If you look at the slide, we have two pictures there. The first picture there is your silica. You can see that is white, and the second one is sand. Don't forget that your silica is gotten from sand, and your silica, when you get your silica, you can use it to produce your glass. So the first thing is you extract your raw material. You extract your raw material, which is silica. And silica is the main component of glass, and it is obtained from mining or dredging sand from natural sources such as the beaches, riverbeds, or quarries. You can see on the picture, on the slide, we have the picture of a beach there. So the sand gotten there, you can process it into silica, and from there to your glass. So the first step is to extract your raw material, after which you will go into the glass formation. Your extracted silica alongside with soda ash and limestone is mixed together and heated to high temperatures in a furnace. So this mixture undergoes a process called fusion. The process that this mixture undergoes is called fusion, and in the process it melts and transforms into molten glass. If you look at the picture there, you have something like a glass that is flowing. So it has been transformed into a molten glass, and after this you move to glass shaping. You shape your glass to the form you want it, and you can do this by, we have techniques of shaping it. We have the blowing techniques, we have the molding techniques, and we have the pressing techniques. On the picture there, we have the blowing techniques to shape the glass into the various shape you want it to come out in. So this allows for the creation of different glass products such as bottles, windows, mirrors, glassware, and any glass products you can think of. These are the procedure it takes. When you extract it, then you form it, and from there into a molten form, and you shape it into the shape or whatever you want it to come out as. And number 4 is cooling and annealing. After shaping, the glass is gradually cooled to room temperature to ensure its strength and stability. So it must be cool first before you package it and take it out, maybe to sell or for the usage or whatever thing you want to use it for. This process, known as annealing, reduces internal stresses and enhances the durability of the glass. So glass is used in a wide range of industries and applications. In the construction industry, we can see in the production of windows, doors, and architectural features. So providing transparency, natural lighting, and insulation. So glass packages such as bottles and jars is commonly used in the food and beverage industry. We have looked at it in the construction industry, or that is when you use it in the building industry. I mean to say, for your doors and windows, even furnitures. Now in glass, we also have it in glass packaging such as in bottle and jars. It's also used in food and beverage industry. An example is our Coke and Fanta. Those bottles used, I don't mean the plastic bottles, I mean the glass bottles used are made from glass, from glass, and that's why we call them glass bottles, and they're used to package those food products. It also finds application in optics, telecommunications, electronics, and in automotive sector, contributing to the production of items like lenses, that means glasses. We call them glasses, but in the real sense they are called lenses. That means the eyeglass, whether it is for short-sightedness or for long-sightedness or for ever eye defects. So you can see that glasses have been used in the production of these lenses, fiber optics, display panels, and windshields. For example, this windshield, we have it in our cars. We have it in the cars. The glasses, the mirrors, and also we call them the front windshield and the back windshield. They are all made of glasses. So very quickly, we're going to look at the properties of glass. The properties of glass. Number one property is transparency. Glass is known to be transparent. That is its nature. All glasses that you see, they are transparent, allowing light to pass through it. That means light can pass through it. This property makes glass suitable for applications like windows. Your windows is transparent. Lenses, that means eyeglasses, they are transparent, and display screens, they are transparent. On the slide there, you have a mirror there. So this transparency property has made it useful in the production of these things that I mentioned. And number two is brittle. Glass is brittle, is a brittle material. That means it can break. When we say something that is brittle, that means it tends to break or shatter when subjected to stress or pressure. When you apply pressure on it, you can see that it can break into pieces. However, various treatments such as tempering or laminating can enhance its strength and safety. But when much pressure is put on it, it can break. So brittleness is one of the core properties of glass. Number three is smooth surface. Every glass you come across, you see that they have a smooth surface. When you run your hands through it, it's very smooth. It's not coarse in nature, it's very smooth. So glass has a smooth surface that offers low friction, making it ideal for application like tabletops, mirrors, and laboratory equipment. So that smooth surface, that property it possesses, has made it useful in these applications that I mentioned. Number four is heat resistance. Heat resistance. Glass exhibits good resistance to high temperatures, making it suitable for application in industries such as cooking, lighting, and scientific experiments. I don't know if you've carried out some scientific experiments, maybe in your lab, in your school lab. You see that sometimes we put some glass on fire in the course of our experiments. Maybe you have some chemicals you need to apply heat to, you put them on fire, and their resistance to heat, they don't break easily, they are resistant, they don't melt, unlike rubber that when you put them on fire, they melt. Number 5 is electrical insulation. Glass is an excellent electrical insulator, preventing the flow of electricity. Preventing the flow of this property makes it useful in applications involving electrical components and insulating materials. As you can see on that pole, it is the insulating material there is glass. Is glass. That is what. So it is used in insulation. It is a good electrical insulator. So we're going to go to the next resource that can be gotten from non-living things, which is ceramic. The first one is glass, and we're moving to ceramic. And now we're going to look at ceramic production. How the first question we had was, how is ceramic molded? Here is going to be discussed extensively. So in ceramic production, ceramics are another important resource derived from non-living materials. They are not derived from living materials, they are derived from non-living materials. They are created by shaping and firing a mixture of clay. So the main parent material of ceramic is clay and other inorganic materials. I don't know, maybe you've ever stopped to think that what is the relationship between clay and ceramic, but this is it. It's here. Clay is the parent material of ceramic. So when you want to make your ceramic, one of the major ingredient that you need is clay. The process of ceramic production involves the following steps. Let's look at the production. Number 1 is raw material preparation. So clay, which is the main component of ceramic, is extracted from natural sources like clay pits or mines. You can get your clay from clay pits or mine. It is then processed to remove impurities and achieve desired consistency. It goes through some processes and whereby the impurities in it are removed, and to achieve your desired consistency depends on what you want to use it for. But do not forget, it is for ceramic now, so it passed through that process through which it will have a desired consistency. Number 2 is shaping. So when you have removed the impurities and you already have your desired consistency with the clay, you shape. That the prepared clay is molded into the desired shape through techniques like hand molding, such as we have on the slide. You can see a man with his 2 thumbs in the clay and is rolling. That is hand molding, or wheel throwing, or through extrusion. That is how you shape your clay into your desired shape, the desired shape you want. These steps allows for the creation of ceramic products with diverse forms, including pottery products, tiles. I know you're surprised that your tiles are made from clay. Yes, your figurines and sanitary ware, they are all made from clays. Number 3, drying. So once you've shaped it into your design, what you want it to be, and the next thing is to dry it. So once the ceramic needs to be dried to remove moisture content, and there are 2 ways by which you can dry. You can air dry, just like we have in the first picture there, that is air drying, or by using specialized drying chambers, such as we have in the second picture, specialized drying chamber, so that it can be hard to be able to. So if it's not hard, you can't package it, you can't use it, it's not usable, so you must dry it. Number 4 is firing. The dried ceramics, you don't fire when it's still wet. It is after it is dry that you fire. The dried ceramics are subjected to high temperatures in a kiln. Where it is subjected to high temperature is called a kiln. That is where it is being fired to achieve a chemical and physical transformation. During firing, the clay particles undergo a process called sintering, where they bond together and become solid. This results in the hardening and straightening of the ceramic product. If you touch your ceramic plate or your ceramic cup or ceramic spoon, you see that it is hard. Or if you enter your restroom and you touch maybe your bathing tub, it is hard. And these are your tiles, they are hard. It's because they have been passed through this process called firing in the kiln. So ceramics are valued for their unique properties, such as heat resistance. We're going to consider that when we are looking at the properties of ceramics, hardness and electrical insulation. They find extensive use in various industries, including in construction industry, household goods, electronics, aerospace, and health care. You're surprised. Yes, healthcare, ceramics find its usage too in healthcare. Ceramic tiles are commonly used for flooring and wall coverings due to their durability and aesthetic appeal. Whenever you enter a building and you see a tile, know that this is clay. It is made from ceramic. This is ceramic tiles, and it is made from clay. And advanced ceramics such as alumina or zirconia are used in specialized applications like cutting tools, electronic components, and dental implants. Let's look at the properties of ceramics. One is hardness. Don't forget that what helps it to form this property is fire. When you fire it, that's when it's hard. So one of the number one properties of ceramic is hardness. Any ceramic you touch, you start, they are hard. Ceramics are known for their hardness and resistance to scratching. This property makes them suitable for application requiring wear resistance, such as cutting tools and tiles. Your tiles are hard, and it's because of this property that is what makes it suitable for the production of tiles and cutting tools. Number two is heat resistance. Ceramics have high heat resistance and can withstand extreme temperatures without deforming or melting. This property makes them suitable for applications like kiln linings, cookware, and engine components. Number three is brittle. That means similar to glass, just like our glass is brittle, that means they have tendency to break. They can break under stretch, they can fracture when you put them under pressure, they can break. However, the addition of certain materials or the use of specialized manufacturing process can enhance their toughness and fracture resistance. Number four is chemical resistance. Ceramics are highly resistant to chemical corrosion, making them suitable for application in chemical processing, in pharmaceuticals, and in biomedical engineering. Number five is electrical insulation. Many ceramics exhibit excellent electrical insulating properties, making them useful in electrical and electronic applications such as insulators and incapacitors. When some insulators, do not forget I told you that glass also, we use glass for insulator, but you can also use the ceramics for insulators because they do not transmit electricity. That means electricity cannot pass through them, unlike metals, and also you can use them in capacitors. So we're going to the next, which is rubber. Rubber is one of the essential of non-living resource, and they can be derived from both natural and synthetic materials. So natural rubber is obtained from the latex of rubber trees. You can see a rubber tree in the picture, and the latex is being collected into a container to be taken to the industry for processing. So while synthetic rubber is produced through chemical processes, the production of rubber involves the following steps. We're talking about natural rubber and not the synthetic rubber. The natural rubber, number one is latex collection. Just as we have in the picture there, you collect your latex from tree. In the case of natural rubber, latex is extracted from rubber trees. We have a tree called rubber tree through a process called tapping. So what is going on in that picture is tapping. You are tapping the latex from the tree into a container. So this involves making incision in the back of the rubber tree and collecting the latex that oozes out. Once you make an incision in the back of on the back of the rubber tree, you have some fluid coming out. The fluid coming out is called latex. So you collect it into a container. That fluid oozing out, you collect it into a container. That is the process of latex collection. And the next thing is latex processing. The latex you collected from that tree, it undergoes several processes to remove impurity, just like your clay, just like our clay. You take it through processes to remove the impurities, so you can get your desired consistency. Same thing with latex. You take it through a process and you remove impurities, and so that it to increase its rubber content. I mean, to remove those things that are in need that are not rubber, because in the process of you collecting it from the bush or from the forest or from the wherever you're taking it from, there are some impurities that will come along with it. So you have to take it through that process of removing the impurities so that it can increase its rubber content. So these processes include coagulation, where chemicals like acid or lime are added to the latex to cause it to solidify and separate from the liquid. Number 3 is vulcanization. To improve the elasticity, durability, these are properties. We're still going there in the course of this lecture. So to improve this and the resistance of rubber, you take it through a process called vulcanization. So vulcanization involves treating the rubber with sulfur and subjecting it to heat and pressure. So this process cross-links the rubber molecules. It cross-links and resulting in enhanced properties. So it enhances its properties. After vulcanizing it, you go to product manufacturing. So once the rubber is processed and vulcanized, it can be shaped into various forms and products using techniques like molding, extrusion, or calendering. So any of this process or these techniques you choose to take it through is just to get the end product, that is your desired product. So rubber finds application in the industry such as in automotive industry, in construction industry, in footwear industry, manufacturing, and in health care. Rubber is widely used in the production of tires. Most of us will know tires. You see tire in your vehicle or your motorcycle or tricycle, and why it is being used because of its flexibility. We're still going to look at it when we are studying the properties of rubber. Resilience and traction properties are crucial for safe and efficient transportation. It's also used in the manufacturing of belts, hoses, gaskets, seals, footwears, and in adhesives. Synthetic rubber, which is derived from petroleum-based materials. Do not forget when I talked about rubber the first time, it can either be natural or from synthetic. And we said synthetic are gotten from chemicals. So the main chemical that is gotten from is petroleum-based materials, and it's used extensively to meet the growing demand for rubber products. So we can see in a hose pipe there, it is made of rubber. You can see the belt here made of rubber. Shoe, that is in footwear, it's made of rubber. And also in all these in hoses, in all these, they are made of rubber. All these pictures that you see, they are all made of, the products you see they are made of rubber material. So let's quickly look at the properties of rubber. The properties of rubber. Number 1 is elasticity. Rubber is highly elastic, meaning it can stretch and deform under stress. It can also return to its original shape after the stress is released. For example, if you have your rubber ring, most of us are familiar with rubber band or rubber ring. So when you it's the rubber, and that you stretch it. When you stretch it, it can return. When you stretch again, it can return. But once you put it under, when it's reached its elastic limit, it will not return, except the stress is released. This property makes rubber suitable for applications that require flexibility and resilience, such as in tires and in gaskets. Number 2 property is low friction. Rubber has a low coefficient of friction, providing good grip and reducing wear in application like in conveyor belts, seals, and footwear. That's why you can use it in your shoe production. So it has low friction. Number 3 is water resistance. Rubber is generally impermeable to water. Water cannot pass through rubber, any rubber whatsoever. That's why we can fetch our water in a rubber and keep it, and it will still be there. Any day you come back, you still find it there, because water cannot penetrate it, it cannot pass through it, it cannot flow through it. So making it useful for applications such as in waterproofing materials, seals, and in hoses. Number 4 is electrical insulation. So same as we have in glass and ceramic, so we also have it in rubber. It can it's a good insulator. Rubber has good electrical insulating properties, making it suitable for applications in electrical wiring, in cables. Most of the cables you see in your homes, at home, maybe just check around, you see cables, they are made of rubber and in electrical insulation. Number 5 is damping properties. Rubber exhibits excellent vibration and shock absorption properties, making it valuable in applications that require noise reduction and impact resistance, such as vehicle, suspension systems, and shoe soles. When you have your rubber shoes and you're walking with your rubber shoes, it hardly makes noise. That is it. That is the damping properties make it usable in that form. So it doesn't make noise. It is good for to reduce vibration and to absorb shock. So these damping properties make it usable in these applications. So we have come to the end of our lesson, but very quickly I'd just like us to take a recap. We have looked at resources derived from non-living things, and we have looked at the production of glass, the production of ceramic, and also the production of rubber, and also the raw materials that are used in the various production. So very quickly we're going to go to the ExamGuide app to fetch some questions to look at what we've learned and see if we can answer them, which I know definitely we are going to answer them. So you go to, our topic is basic science, you go to the ExamGuide app and also click on basic science. Then you select your topic of interest, which is resources from living things. So we're going to check out some questions very quickly. Okay, I have a question here. It says, which of the following materials is used for making glass? Which of the following material is used for making glass? Yes, we looked at this under glass production. We have A, rubber. We have B, sand. We have C, plastic. We have D, cement. And we have E, clay. So let's go through the options. Rubber, no. Sand, yes. Sand, true. When you process it into silica, and from there your glass is produced. So the right option is sand. Sand is a material, is the material used in the production or in the making of glass. Okay, we have another question here. It says rubber is used for producing the following except. Rubber is used for producing the following except. We have option A, tires. Option B, insulation. Option C, buttons. Option D, buckets. Option E, tubes. Let's go to the option. Option A, tires, yes. Use rubber for the production of tires. Option B, insulation, yes, because rubber is a good electrical insulator, so we use it. C, buttons, no. Bucket, we use rubber. E, we have tubes, we use rubber. So the right option there is button. Rubber is not used in the production of buttons. We have another question here. It says, the following are properties of ceramics except. The following are properties of ceramics except. A, brittleness. Yes, it can break. Ceramics can break under pressure. When you apply pressure on it, it can break. B, non-magnetic. Definitely they are non-magnetic. They don't attract they are not attracted to magnets. Ductility. Ductility is the ability for you to stretch something into a thin wire, to stretch a metal into a thin wire. So that is suspicious. D is resistance. Yes, one of the properties of ceramics is that it's resistance. E is corrosion resistant. Exactly. So the option there is ductility. That's option C. So ductility is not a property of ceramic. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and gives detailed explanations of all the questions at the end of your practice test. You can also learn a particular topic of interest with different modes like study modes, mock modes, and practice modes. It has other features that make learning fun. It is a must for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Do not forget to subscribe to our channel and hit the notification bell and share the video with others that will benefit from it. Bye for now.